I'm Becky Close. I manage the air quality policy section at the Division of Air Quality. And before I launch into slides today, I'd asked our director, Bryce Bird, for some words of wisdom. And he gave me a task instead. So we have, I don't know how many of you have heard of the Air Quality Policy Advisory Board, but it's a board made up of legislators, academic community members, as well as advocates in industry. And it's a group that meets, and I'm going to read to you straight from the bill, a group that meets to seek the best available science to identify legislative actions to improve air quality, identify and prioritize potential legislation and funding that will improve air quality, and make recommendations to the legislature on how to improve air quality in the state. We recently added extra spots for academic members to this board, and we need one more, and the one person needs to not be from the University of Utah. So Heather Holmes and Carrie Kelly have been amazing on the board so far, and we're looking for one more academic member for that board. So it's a pretty low time commitment. I think it's about once a week during the session for the first month for about an hour at a time. And then throughout the rest of the year, it's about 1 to 1.5 hours, I think 6 times throughout the rest of the year. So fairly low time commitment. And if you have questions more about the time commitment, you can talk to Carrie Kelly, I don't know where she is, or Heather Holmes. They can fill you in. And just let me or Bryce know if you're interested. All right, so there's our words of wisdom from Bryce. All right, so just why we're all here. I love this figure. This shows all the Utah-based health studies that show air quality impacts, Utah-based studies that show air quality impacts, all this research that all of you have done over the years. And so it's why we're all here. We know that poor air quality affects health, and we know that the EPA sets national ambient air quality standards in order for us to meet those health-based standards. So, it's why we're all here. When we can't, as a regulatory agency, when we can't meet a national ambient air quality standard, we write what's called a state implementation plan. I'll get to that in a minute. But I just want to say here that this is really why you all are so important, is because you bring this research that affects really, in the long run, how EPA sets the NAAQs. And so what is a state implementation plan? I know most of you probably know all of this, but I'm just going to go over it really quick. So it is a all-inclusive document that outlines how a state is planning to attain an NAAQs that they're out of compliance for. When I say all-inclusive, it's got rules, regulations, inventories, and attainment demonstration. And the Clean Air Act is really specific with what needs to go in a SIP. And I think as I was thinking about, really how we all support each other, I was thinking that the Clean Air Act is very prescriptive. So it tells us the specific things that we have to do. And I think a lot of what's fun about a research community is that we take all your information and we can go a little bit beyond what the Clean Air Act tells us we have to do. And so, if we want to control something that is a little bit out of what's prescribed by the Clean Air Act, we take your data, and your data gives us good reasons to bring good policy. Let's see, and then I think this is probably obvious too, but as I mentioned, that SIPs need attainment demonstrations, which are based on photochemical modeling. And of course, many of you help us improve our photochemical models, and that's incredibly important. And then of course, inventories are the basis of all the work that we do. And so continually improving those inventories, improving the photochemical modeling, ultimately gives us better policy in the end. And we couldn't do it well without you. So, okay, so I'm going to talk a little bit about PM 2.5 and then launch into ozone. So we've come a really long way with ozone in the last several decades, or sorry, with PM 2.5. In the last several decades, we had 3 non-attainment areas that were out of attainment for the 2006 24-hour standard. One of those areas has officially been redesignated to attainment by EPA, which is a big hurdle. The Logan area is in the first of 2 10-year maintenance periods right now. Salt Lake, we've turned everything into EPA. They're reviewing. They're a little bit stuck on some of the major source controls that we submitted in the SIP. So we are working through that right now. And then the Provo area, EPA tells us will be redesignated pretty soon in the Federal Register. So we've come a long way. However, I was at a meeting yesterday and EPA announced that they're looking at lowering the PM 2.5 standard to between 25 and 30, the 24-hour standard. So we're probably going to have a lot more work to do here pretty soon. And I'll be looking for a PM 2.5 coordinator pretty soon. And so as some of that PM 2.5 work was ramping down, ozone's ramping up. So we have 3 areas again in Utah that are out of compliance for the 2015 ozone NAAs. And we're going to go into a lot more detail on that, but the northern Wasatch Front is classified as marginal. So when you're out of compliance for a NAAs, you kind of go up in classification as you maybe can't attain that NAAs. And so the lowest classification for ozone is marginal. We didn't attain by the attainment date, so we're expected to be bumped up to moderate. Also from the meeting yesterday, I heard that's going to happen within 2 weeks, but they've been saying that for like a year, so we'll see. We'll see. Southern Wasatch Front did attain the standard by the attainment date, and so we'll be working on someday a maintenance plan for that. It's kind of on the bottom of our list right now. And then the Uinta Basin, Sheila's going to go into a lot more detail on that in a little bit. So, all right. So we've got Ryan and Sheila here. They're our ozone coordinators, and they're going to dive into some more detail for you.
Great. Can you hear me well? Can I have the thank you? So as Becky mentioned, my name is Ryan Bars, and I'm the ozone coordinator for the WASatch front. And as Becky mentioned, we are expecting to be bumped up to moderate relatively soon, apparently within the next 2 weeks. And so with that, we're fully into the SIP planning and development phase. And so with that, our goal is to try and find a 15% reduction in VOCs. And the years that you see there on our inventories are pretty important for this. Our base year is 2017 and our projected year, so the year of attainment is 2023. So that 15% reduction in VOCs needs to come from those periods of time. Within the development, we're also full on into our CAMEX modeling. I'm not going to be talking at all about that because Nancy Tahir is going to be giving a talk just after lunch, where she's going to be overviewing all the great work that her and her team have been doing to refine the model and has some really exciting results. So if you have questions about modeling, I strongly recommend you attend that. And I'm sure Nancy can answer all of your questions. Whoops. There we go. We're also full on into the control identifications and rules development phase. So we're really looking for what sort of rules can we implement to find that 15% reduction. And then lastly, we're also in the process of doing our stakeholder meetings, and I'll briefly touch on that towards the end. So I wanted to really quickly start out with our inventory. So this is our 2017 VOC inventory. It's important to note this is anthropogenic emissions only. So you won't see biogenics or wildfire on here because at the end of the day, ultimately, we can only be responsible to control the emissions for which we're responsible for. So if you're wondering why those aren't on here, that's why. I do really quickly want to draw attention to kind of the 4 largest contributing sectors in here. So you can see solvents, on-road, non-road, and non-point. And the point here is that really all of these emissions are occurring in a fairly distributed way. Instead of seeing a couple large point sources dominating these emissions, the VOC inventory is definitely more developed with, or is being emitted much more distributed throughout the valley. So solvents, we have things like household products and paints. On-road, of course, is our traffic. Our non-road is, anything with an engine that can move around that's not a car. So here we're talking lawnmowers and leaf blowers. And of course, non-point is kind of your traditional area sources paired with solvents. So again, we're really seeing the shift towards distributed emissions throughout the valley. Now, I will say Lexi Wilson has a poster about some tools that she put together that will allow you to really dive into the inventory. So if you want to know a lot more about our inventory, visit Lexi's poster during the lunch break. So that kind of brings us to some of the outstanding questions, scientific questions. What can you all help us answer in this SIP development process? And really, this slide could probably be 20 plus bullets, but I've tried to focus on just a couple of the big ones. So the first is halogen chemistry. We know we have a large point source emitter of halogens and brominated compounds. So understanding those emissions with the added complexity of the emissions of the Great Salt Lake, and understanding one, the emissions, and then two, how is this impacting the secondary and tertiary chemistry associated with ozone formation along the Wasatch Front. Changing emissions, so I just mentioned that we're seeing very distributed emissions occurring, but of course, we're also seeing significant impacts from exceptional events. We all know we had quite the wildfire season last year, and added on top of this, we also have changing population, growing population. So understanding those emissions dynamics and accurately representing them moving forward is going to be critical in our understanding of emissions. And then lastly, NOx to VOC sensitivity. I don't think you can talk about ozone without talking about NOx to VOC. And so we do know through some really good work that has recently been done, the Northern Wasatch Front is in a VOC limited to a transition phase, depending on the time of day. And I'll touch on that briefly in a second. But that does raise some questions about, as we control emissions and as populations change, how is that sensitivity going to evolve into the future? So I'm going to touch just briefly on this. I'll point out another poster. Mark has done some great work looking into VOC and NOx sensitivity in the Wasatch Front. And the main point here is the graph on, I guess, your right there, showing kind of the diurnal patterns of VOC to transition VOC sensitivity there. So we are seeing periods of the day we are fully VOC limited, and then later we move into kind of a transition phase where NOx or VOC controls could have a fairly good bang for their buck. So understanding these profiles at multiple locations, and again, understanding what they'll look like in the future, is going to be pretty critical to this as we look for policies that will have a really good impact. I did want to really quickly thank all of you who were able to participate in our first public outreach meeting. We have a landing page here that if you weren't able to attend, I recommend you check out. This is where we're hosting some interactive inventories, and you can download our 27 inventory there. And if you have ideas for emission controls, like I said, we're definitely fully into the rules development phase. There's a form on there that you can use to submit those ideas. And you can leverage the inventory to add up some emissions if it helps with that. And I just wanted to finish really quickly on this point, kind of covering how it is we take an idea that we have or has been brought to us through all of your hard work and actually turn that into a rule that results in emissions reductions. And so this is kind of the standard rulemaking process. Again, this is really where we're at with the Northern Wasatch Front SIP on the policy side of things. So we begin with our advanced notice of rulemaking, where we start engaging with the source that's going to be impacted by this, the regulated entity, and make sure that they really understand what it is we're trying to do and understand the language and help us draft the language in a way that does what we're targeting. We then propose that to the board. Randy can tell you all about this. So if you have any questions, bug Randy. And if they agree with it, they'll send it out for public comment, 30-day period where the public and anybody, including the source that's going to be regulated, can comment on that. We take those comments, respond to them, and make any changes necessary to the rule based upon those. And then lastly, we propose it to the board again. If they agree with it, it becomes adopted, becomes an administrative rule, and then ultimately we can use it in the SIP to show our 15% reduction. So with that, I'm going to hand it off to Sheila, who's going to cover the Uinta Basin.
Great, thanks Ryan and Becky. So yeah, the Uinta Basin, one of our marginal non-attainment areas for ozone. We did not actually attain by the August 21 date as was prescribed by EPA's. So, but we have met the requirements to ask for extensions. And actually, we asked for a 1-year extension last March, and we have now just recently submitted our second 1 year. It has been mentioned, EPA has yet to act on those extensions, but we feel pretty positive. We've met all the requirements, which basically meant for the last two years, we've actually been able to, well, I will say in 21, we stayed under the 20, we stayed under the standard. 21, we had a couple exceedances, but you get to average those 2 years. And as long as you're below 70, you get asked for another extension. So my work is done. We're good. No. Your work is done. No. So yeah, that's kind of where we're at. And because of that knowledge that we have with the monitoring and where we're at, and because of staff resources, in the last couple months, previous to that, this last year, we've been very focused on both areas and trying to get inventories together, working on modeling. And as awesome as the folks are at DAQ, it was getting hard to balance both. So we have an opportunity now to focus on the WASatch front because, again, we're pretty certain that that's going to be bumped up to moderate. And then our work isn't done in the basin, and then we can transition to that later on, hopefully. So because of that, we did get to a certain point where we were able to take our 2017 emissions inventory, backcast to 2013, where we had a pretty significant ozone event in the basin, and start to work on modeling. So we were able to get a smoke run done. Our magician Lexi has been able to start work on that. So we're able to look at daily ozone values. So picking an ozone day in February of 2013 and look at what are the emissions at a daily rate. And I apologize, these aren't the best numbers, and we'll share these slides with you. And I hope to, once we've kind of worked through the Wasatch front, we will work on this and be able to talk to stakeholders and present this data in a better format. So this is sort of unreviewed, but I think interestingly, it'll show you our NOx and VOCs in the basin. Pretty significant bars there that show the EGU. I think there's only one. And I know there's been a lot of work done on how does that influence ozone or not, but from an emission standpoint, that is our NOx source, largest NOx source. And then oil and gas is behind that. And then actually we get down into mobile sources for NOx emissions. VOCs, no surprise to anyone. There's a very large red bar there for oil and gas. That is pretty much 97, 98% of the emissions in the Uinta Basin. And this is very small, I know, but this is kind of, I like how Lexi has presented this and where it shows the significant contributors to NOx and VOCs. Again, you can see the EGUs, oil well heaters, artificial lift engines, compressed engines. Those are kind of our NOx sources, our major NOx sources we're looking at in the basin. And on the other side, the VOCs, oil well tanks actually are our largest VOC emissions. And interestingly enough, though EPA has about 75, 80% of the emissions on federal land, Indian country, versus the 20, 25% on state jurisdiction. We at the state of Utah actually have more of the oil tanks, and Indian country and EPA have jurisdiction over mostly gas. So we kind of have a little weighting there that maybe oil tanks have a pretty significant VOC contribution. And then skim ponds, artificial lift engines. We have updated the 2017 inventory with some engine work that's been done by USU CES group, as well as EPA has gone out and done some compliance testing on engines in the basin. So they actually have moved up the chain in terms of a significant VOC contributor, and actually also reactive VOCs. So something for us to be looking at in the basin. Okay, I'm a policy person, not a scientist, even though they call me an environmental scientist. So you guys know this better than I do, but in terms of some of the questions we're looking at in the basin, snow chemistry, the interaction of the snow with aerosols, and the influence of nitric acid. almost forgot what HONO was. And then, as I was just mentioning, we're receiving more and more data about engines in the basin. And so we're interested in understanding that emissions source. And ultimately, how can we work on these engines? What can we do to reduce the emissions and alternatives to engines? And that's a huge challenge in the basin. Electrification would be the answer, but that's not going to happen. It's pretty expensive, but we are starting to look at some other alternatives for how we can reduce those emissions. And then similar to the WASatch front, the NoxVOC sensitivity, there's a belief that it's NOx limited, but I think the role of the reactive VOCs is pretty important also in terms of the formation of ozone in the basin. We're done. Questions?
I'm just gonna hand this to you. I'm not a thrower.
On the NOx for the Uinta Basin, you showed that the power plant out there had significant NOx. But during inversion events, isn't that basically above the inversion height? So, I mean, are the models accounting for that?
And I don't know if I'm the best person to answer that, but Lexi's nodding at me, so yes. But yeah, I know, I think there's kind of a picture that's been shown throughout the years of where there's an inversion, and they show the stack of Bonanza, and you can see the plume
Right.
spreading out above the
And
inversion.
I believe some of the NOAA flights way back when verified that that was staying above the inversion as well.
Right, and I think just from an inventory perspective, we're showing that, but hopefully through the modeling, we'll work our way through that to whether it's influential or not.
Okay. Thank you.
Mhm.
Do you want me to throw this to you? Okay.
Just a quick question for Becky on PM2.5. So you mentioned, obviously, the KSAC's looking at revising the PM 2.5 standard, but you only mentioned 24-hour. Have you guys looked at the potential impact of the change to the annual standard?
We have, yeah, so they're looking at between 8 and 10 micrograms for the annual standard, and we definitely have some areas that would be above that. Especially with all the wildfires during the summer.
We have a question from the chat that I'm going to read. Pretty lengthy. Okay. Ryan showed a slide suggesting the Wasatch Front is mainly VOC limited and transitional between NOx and VOC. Please explain this vis-a-vis large reduction in both NOx and VOC that have not lowered ozone concentrations.
Yeah, so that's a great question. And the question is really whether or not the past emissions reductions that we've implemented in the Wasatch Front are impacting our ozone concentrations. And I think this is a question that is actually kind of still outstanding on the science side of things, because what we measure at the monitor isn't necessarily representative of all the local photochemistry that's occurring. A lot of things get baked into that 8-hour average number. So things like wildfire impacts, transport, just generally background ozone concentrations as well. And so I don't think we can definitively answer the question as to whether or not previous controls, reductions in VOCs and NOx have impacted or haven't impacted our local ozone numbers. I hope that answers the question.
He's right. Anybody
And I
else?
encourage you all to look into this.
Not seeing. I'll talk into this. I'm not seeing any additional questions in the chat. Does anyone in the audience have any more questions that I just can't see? Oh, Randy was going again.
And maybe this question is really for Bo, wherever Bo is back in the back somewhere. Oh, there he is. My thought on that last question with you about historical ozone and the NOx and VOC reductions, am I wrong in that didn't we used to see a lot higher concentrations of ozone overall in the Salt Lake Valley?
Here you go, Randy.
So yes, we have seen a lot higher ozone concentrations historically. So the ozone numbers have been coming down. I would say that just because we exceed the standard enough times to actually be non-attainment doesn't necessarily mean the air is getting any worse. It's definitely getting better. One of the things that we can look at is that the number of times that we've exceeded the standard and years ago, let's see, I think according to this graph, you can see that we exceeded the standard here, 20, 30 times in a year. And last year was really bad for wildfire, but if you look at since like 2013, most years we have a lot fewer days that we exceed the standard. And I'm not sure exactly where all the data comes from, but one of the things is that the more monitors we have, the more days that we exceed, because we might exceed it 5 monitors on the same day. And so I'm not sure exactly how it's being counted, whether that's individual days or not. However, the form of the standard is the 4th high. So once you get to the 4th high at one site, that's the number that you look at. And what we see is that, currently the standard is 70. Back when the standard was 75, we barely were, not meeting 75. And because of the change in administration at the time, they put a hold on while they reviewed the standard. In that time while they were reviewing it, we managed to get just to 75. So we were attainment. And then a few years later, they revisited it and changed the standard to 70. And that's when we became non-attainment for ozone. Over the years, the numbers have been getting closer and closer. We were just bang on at 75. And we're, so they've been getting better. We have seen historical numbers in over 100. And so they have been a lot higher. And now when we see high values, they don't go nearly as high normally, but they still exceed.
Expo, and you can actually see that in this graph. If you look at the 2000 and 2001 numbers, the number of days that are in that very unhealthy category are much higher, and those have pretty much disappeared from the graph as we move forward.
So when we went from 75 to 70, at that point in time, my recollection is that the EPA was vacillating between 65 and 70. Has there been any consideration that they might bump it down to 65 and make this even more challenging?
Yes, I think that's probably in our future. They're getting through the PM 2.5 NAAs review first right now, and then they're going to revisit the ozone standard. Trying to recall what they said yesterday, but they said we'll be looking probably for those when they lower the standard. They said we'll probably be looking at 2022 to 2024 or 2023 to 2025 data for initial classifications and designations. So yeah, it will likely lower.
Ended up at the microphone. Maybe this is a question for Seth and Mark, but it seems like there's a strong correlation between snowpack out in the Uinta Basin and these high ozone events. Have we just gotten lucky because it hasn't snowed out in the Uinta Basin? Or are we going to be in trouble again as soon as it does start to snow someday when my prayers are answered?
Well, the connection with the snowpack has to do with the albedo of the snowpack. So we never see high ozone unless there's a good snowpack. Ligi's going to address this, I think, in her talk. One of the reasons we think, correlation is not causation, but we think the main reason that there is not as much ozone these days has to do with the decline in the industry. So.
Haven't seen as much inversion episodes either.
I think we have.
Well, Mark wrote a paper where he basically corrected for meteorology and still sees a decline. So that might be changing, though. Things are, we only had a couple days this winter with snow on the ground, and ozone jumped right up like the good old days in 2013. So it may be going in the other direction now that the industry's turning around.